Class 11 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 4 Calculus. Topic Derivatives. Subtopic Derivative introduced as rate of change both as that of distance function and geometrically. Definition of derivative: relate it to slope of tangent to a curve. Derivative of sum, difference, product, and quotient of functions. Derivative of polynomial and trigonometric functions. Exercise 13.2. Derivatives. Derivative of a function f at x equal to a. Suppose f is a real value function and a is a point in domain. The derivative of a function f at x equal to a is denoted by f dash of a and is defined as f dash of a equal to limit of f of a plus h minus f of a by h tends to 0 if this limit exists. Derivative of a function f at any point x. The derivative of a function f at any point x is defined by f dash of x equal to limit of f of x plus h minus f of x by h tends to 0. Geometrical meaning of derivative of a function y equal to f of x at any point in its domain. Geometrically, the derivative of a function y equal to f of x at any point in its domain is the slope of the tangent to the curve y equal to f of x at the point. Physical interpretation of derivative of a function y equal to f of x at any point in its domain. Derivative of a function s equal to f of t at any point in its domain is velocity. Fundamental rules on differentiation. Derivative of sum of two functions is sum of the derivatives of the functions. Derivative of the difference of two functions is the difference of the derivatives of the functions. Derivative of product of two functions is first function into derivative of second function plus second function into derivative of first function. Rule number 4. Derivative of quotient of two functions is b into du by dx minus u into dv by dx by v square. Derivative of constant into a function is constant into derivative of the function. 6. Prove from the first principle that d by dx of c is 0 where c is a constant. 2. d by dx of x to the power n is n times of x to the power n minus 1. This rule is also known as power rule. 3. d by dx of sin x is cos x. Number 4. d by dx of cos x is minus sin x. 5. d by dx of tan x is sec square x. Number 6. d by dx of cot x is minus cosec square x. Number 7. d by dx of sec x is sec x tan x. d by dx of cosec x is minus cosec x cot x. Mafam asida kona hauba function singi trigonometric function singi derivative ta minus na mamang thangani. Habisi khangjan bayai. Solution 1. Let f of x equal to c where c is a constant. Therefore, f dash of c using appropriate formula we get f of c plus h minus f of c by h. Limit of h tends to 0. F of c plus h for constant function, its outcome is c. F of c is exactly equal to c. C minus c is 0, 0 by a non-negative, a non-zero number is 0. And which is 0, whose limit is automatically 0. From which we have learned that d by dx of c that is a constant is 0. That is, derivative of a constant function is 0. 6. Continued. Number 2. Let f of x equal to x to the power n. Therefore, f dash x is equal to limit of f of x plus h minus f of x by h tends to 0. We see f of x plus h whose functional value is x plus h whole to the power n. For f of x, it is x to the power n by h. Using appropriate formula, denominator can be written as h can be written as x plus h minus x. H tends to 0. Using most appropriate formula, that is, remember, limit of x to the power n minus a to the power n whole divided by x tends to a, x minus a, when x tends to a is n times of a to the power n minus 1. Using this formula, we get for this n times of x to the power n minus 1. Therefore, d by dx of x to the power n is n times of x to the power n minus 1. Number 3, let f of x equal to sine x. It is a trigonometric function. Therefore, f dash x is limit of f of x plus h minus f of x by h tends to 0, whose functional values are sine of x plus h minus sine x by h. Express difference is product of two trigonometric functions. Sine of something minus sine of something is 2 cos of their sum divided by 2, we get x plus h by 2 into cos sine of x plus h minus x by 2, that is h by 2. Rearranging, we get limit of cos of x plus h by 2 when h tends to 0 into limit of sine of h by 2 whole divided by h by 2. The above function can be rewritten as this, whose limit is obtained when h is 0, that is cos x, whose limit using appropriate formula, that is sine limit of sine x by x tends to 0. Applying that result, we get 1, and cos x we get. Therefore, d by dx of sine x is cos x. Number 4, let f of x equal to cos x. Therefore, f dash x equal to limit of f of x plus h minus f of x by h tends to 0. Giving their value, that is, for this we have cos of x plus h minus f of x is cos x. Express this difference into product using appropriate formula, we get 2 sine of their sum by 2, that is x plus h by 2 into sine of x minus h by 2, that is minus h by 2. Rearrange, we get this limit minus before the limit, and the sine limit of sine of x plus h by 2, h tends to 0 into limit of h sine h by 2, h by 2. The given function can be rewritten as, whose limit is, put h equal to 0, we get sine x, whose limit is 1, that is minus sine x. Hence, d by dx of cos x is minus sine x. Number 6, 5, let f of x equal to 10x. Therefore, f dash x, use this formula, giving its value 10 of x plus h minus 10x by h, whose value is express 10 of x plus h by sine of x plus h by cos of x plus h, and for 10x it is cos sine x by cos x, and sum up, express 10 this 10 in quotient form and sum up, we get this. Numerator is the expansion of sine of x plus h minus x, and denominator remains unchanged. Cancelling x, we get sine h, that sine h by this. Rearrange, we get sine h by h tends to 0. Limit of remaining function, that is 1 by of cos of x plus h into cos x, whose limit is 1, whose limit is obtained when h is 0. That is 1 by cos square is sec square x. Therefore, hence d by dx of 10x is sec square x. Do yourself others. Number 7, prove that limit of e to the power x minus 1 by x tends to 0 is 1. Solution, we have 1 by of 1 plus modulus x is less than or equal to e to the power x minus 1 by x, which is also less than or equal to 1 plus e minus 2 times of modulus of x, where x belongs to closed interval minus 1 1 subtracting 0. Also, limit of left function is 1 divided by limit of denominator, which is also limit of modulus x is 0, which gives 1. Limit of limit of right function is limit of first function plus limit of second function. E minus 2 is constant. We have put it before the limit, and the limit of modulus x tends to 0 is 0, and 0 into something is 0, which gives 1. By sandwich theorem, we get limit of this median function is 1, as limit of this function is 1, limit of this function is also 1, therefore limit of this function is automatically 1. Prove that limit of log of 1 plus x to the base e divided by x tends to 0 is 1. Let us prove. Let log of 1 plus x to the base e by x be taken as y. Cross multiply, we get this, and which is converted into exponential function. 1 plus x is equal to e to the power xy, and e to the power xy minus 1 divided by x is 1, and which is expressed as product e to the power xy minus 1 by xy into y equal to 1. Taking limit on both sides, we'll get limit of first function into limit of second function into limit of 1 is automatically 1, and whose limit is already found to be 1, and which is remains unchanged. This gives limit of y x tends to 0 is 1. Y is replaced its original value. We get limit of log of 1 plus x to the base e by x tends to 0 is 1. Hence proof. Exercise 13.2. 1. Find the derivative of x square minus 2 at x equal to 10. Let f of x equal to x square minus 2. Therefore, f dash of 10 is limit of f of 10 plus ice minus f of 10 by ice tends to 0. F of 10 plus ice, whose value is 10 plus ice whole square minus 2, minus f of 10 is 10 square minus 2 whole divided by ice. Expand numerator and cancel, we get this, and divide ice in its term of numerator, we get this, as ice is never 0, and which is polynomial in ice, we have to put ice tends to 0 to get its limit, that is 20. Question number 2. Find the derivative of x at x equal to 1. Let f of x equal to x. Therefore, f dash of 1 is limit of f of 1 plus ice minus f of 1 by ice tends to 0. Their function values for f of 1 plus ice, its function value is 1 plus ice itself. F of 1 is 1 itself. Cancelling 1 1 and remaining ice divided by denominator, we get 1, and whose limit is also 1. Therefore, f dash of 1 is 1. Number 3. Find the derivative of 99x at x equal to 100. Let f of x equal to 99x. Therefore, f double dash of 100 is limit of f of 100 plus ice minus f of 100 whole divided by ice tends to 0. Function values are 99 times of 100 plus ice. For this, 99 times of 100 by ice. Cancel, we get 99. Number 4. Find the derivative of the following functions from first principle. We have to find out their derivatives from first principle. Let f of x denote x cube minus 27. Therefore, f dash x is use this formula, put their values, that is x plus x whole cube minus 27 minus f of x is x cube minus 27 by ice. Cancel x cube and 27, we get after cancelling 27, we have to complete a standard result, and whose limit is 3 times of x to the power 3 minus 1, that is thrice x square. For Roman number 2, let f of x is x minus 1 into x minus 2. Product, we get this x square minus thrice x plus 2. Therefore, f dash of x is use this form equal to this, and giving its value is x plus ice whole square minus thrice of x plus h plus 2 minus f of x whose functional value is this, and expand, we cancel, we get this, and whose limit is, put h equal to 0. This is the standard result whose limit is 2 times of x to the power 2 minus 1. Limit of constant is constant itself. We get twice x minus 3. For Roman number 3. Let f of x is 1 by x squared. Therefore, f dash x equal to this. And giving their respective value, we get this. And sum up, we get this. And rearrange, cancelling x square from numerator, we get this. And put h equal to 0 in h equal to 0, we get this. Simplifying, we get this minus 2 by x cube, which is the required derivative. Roman number 4. Let f of x is x plus 1 by x minus 1. Therefore, f of dash x is equal to this. Put their respective values. For this, we get this. For this, we get this. Sum up, we get this. And expand numerator, we get this, and cancel. Lastly, we get minus 2. And put I whose limit is obtained when I is 0. That is, put I is equal to 0, we get this, which is the required derivative. Number 5. For the function f of x equal to x to the power 100 by 100 plus x to the power 99 by 99 plus up to x squared by 2 plus x plus 1. Prove that f dash of 1 is equal to 100 times of f dash of 0. Here f of x equal to this series. Therefore, f dash x is, applying power rule, we get this by this. For this, we get this by this. For this, we get this by this. For this, we get 1. For this, 0. And cancel, we get this. Therefore, f dash of 1, x is replaced by 1, we get this. How many times 1 is added? 1 is added up to 100 times, we get 100. Also, put x equal to 0, we get 1. Therefore, f dash of x is equal to, this must be 1. This must be 1. This must be 1. There is, this must be 1. F dash of 1 equal to 100 times of f dash of 0. Hence proved. Question number 6. Find the derivative of this function for some fixed real number a. Here the function is this. Therefore, f dash x is applying power rule for whose derivative is this, whose derivative is this, whose derivative is this, and for whose derivative is this, but whose derivative is 0. Therefore, f dash of a, x is replaced by a, we get this. Simplify, we get this, which is the required derivative. 7. For some constants a and b, find the derivative of this. Roman number 1. F of x is equal to, we get this. Therefore, f dash of x is f dash, it must be dash, is x squared whose derivative is twice x, whose derivative is minus a plus b times of 1, whose derivative is 0, we get this. For Roman number 2, f of x is this, expand, we get this. Therefore, f dash of x is, a square is constant, x power 4 whose derivative is 4x cubed, and twice ab is constant, x square whose derivative is twice x. Twice ab into 2 is 4 times of ab, x, we get plus b whose derivative is 0. For Roman number 3, f of x is this. Therefore, f dash of x is this, applying quotient rule. Quotient rule, that is d by dx of u by v is denominator square, denominator remains unchanged, derivative of numerator minus b dash. Use this formula. Denominator remains unchanged. Denominator remains unchanged in numerator into derivative of x minus a is this, minus numerator remains unchanged into derivative of denominator is this, whole divided by square of the denominator. Factorize, we get this. I. Find the derivative of x to the power n minus a to the power n divided by x minus a for some constant a. Let f of x is this. Therefore, if just x is applying quotient rule, we get denominator square, denominator mathakta lengdana thamo into derivative of mathaki function minus mathaki function lengdana thamo derivative of x minus a gidi 1 minus 0 ni. Expand to all simplify to raga kuni masi phange masi amu. Question 9. Find the derivative of Roman number 4, Roman number 5, Roman number 6. Roman number 4. Y equal to x to the power 5 times of 3 minus 6 times of x to the power minus 9. If actual multiply, we get this. Therefore, dy by dx is 5 songdarabdi 15x power 4 minus 4 songdarabdi plus 24x power minus 5. Roman number 5. Y equal to x to the power minus 4 times of 3 minus 4x power minus 5. Actual multiply tarabadi, we get this. 6 puri we get minus 4 times of x power minus 9. Therefore, dy by dx is 3 times of minus 4 times of x to the power minus 4 minus 1. Minus 4 into minus 9 x power minus 9 subtract minus 1. We get minus 12 x power minus 15 for this plus 36 x power minus 10. Number 6, Roman number 6, let y equal to this. Therefore, dy by dx is dy by dx of 2y of x plus 1 minus d by dx of x squared by thrice x minus 1, whose derivative is applying, whose derivative is x power plus 1 is exponent of a. d by dx of c is length than a thamasi. Ahan bagidi power rule pang for c minus 1 song tarani hani power de ama kaido kro aduga minus we have to put minus here. And apply quotient rule. Denominator do mathak to length thamo into x square derivative twice x minus mathaki function do length thamo derivative of makhaki function, we get this whole divided by makhaki function square. Simplify to over the arm batang si phange ani subagin si phange. Masi amok punchilabadi first ki di length thamani, second ki simplify to the simplest form of phange machine putokada ba derivative aduni. Number 10. Find the derivative of cos x from first principle. Let f of x equal to cos x. Therefore, f dash x is equal to limit of f of x plus h minus f of x by h tends to 0. Put the value of f of x plus h, that is cos of x plus h, and f of x is cos x exactly. Subtract or difference the product of the formula, we get this. Rearrange story minus mamang sakro h plus sine of h by 2 the h by 2 na yellow sine of x plus h by 2 to tongan limit ama lorasi mahakil minus length mahakil limit t h to 0 pira phange sin x mahakil limit t sin x by x tends to 0 ki formula do palabadi 1 phange, we get minus sin x. Number 11. Find the derivative of the following functions. Makhagi functions in the derivative to high bani. Let y equal to sin x cos x lere. dy by dx, the product rule policy, sin x remains unchanged into d by dx of cos x plus cos x remains unchanged into d by dx of first function. Cos x ki minus sin x lere, sin x ki cos x lere. Punjala badi cos square x minus sin square x ne see cos twice x comes manari. So Roman number 2. Y equal to sec x ni mahaki derivative dy by dx lere. d by dx of sec x the sec x then x ne. Roman number 3. Let y equal to this. Therefore, dy by dx the 5 across sec x ki derivative d by dx of sec x plus 4 times of d by dx of cos x. Sec x ki sec x then x learning cos x ki derivative t minus sin x learning, we get this. Roman number 4. Y equal to cosec x mahaki derivative t dy by dx of d by dx of cosec x t minus cosec x cot x. 5. 5 here y equal to 3 cot x plus 5 cosec x, therefore implies dy by dx 3 times of d by dx of cot x plus 5 times of d by dx of cosec x, whose derivative is cot x ki minus cosec square x, therefore we get minus 3 cosec square x plus 5 into cosec x ki minus cosec x cot x ni. Simplify already we get this, which is the required derivative. For Roman number 6, here y equal to this. Therefore, dy by dx the 5 times of dy by dx of sin x minus 6 times of dy by dx of cos x plus dy by dx of 7. Sin x ki the cos x like the cos x ki the minus sin x like the constant ki derivative to 0 ni. We get 5 cos x plus 6 sin x from. Number 7, y equal to 2 10x minus 7 sec x ni. dy by dx the 2 times of dy by dx of 10x minus 7 times of dy by dx of sec x. 10x ki the sec square x ni, sec x ki the sec 10 ni. We get this. Exercise 13.2 supplementary. Evaluate the following limits if exists. Makagi limit sing asi lairabadi evaluate to haibani. Limit of this function ni. Masi standard result ama phangna limit location si assume rearrange tawre kari gidamakta limit of e to the power x minus 1 by it is x by x tends to 0 with the limit standard limit ki value di 1. Si panana bagi damakta e to the power 4x ki 4 lokthokpa ngamdre manhan ge hairabadi makagi x ta 4 na puriro madu balance tawnaba 4 na mathakta purislo we get limit ki mamangna 4 do thame. Asigi limit 4 lerani si pura puri standard result ore. Standard result orabadi 4 into whose limit is 1. We get 4. But pyramid function ki limit ki value is 4 ni. Roman number 2, sisu mu e square kamal lokthokra si maduna limit ki mamang sakare into limit of lemhori by e to the power x minus 1 makhag x to lengan thame x tends to 0 masi exactly mathak ki formula asika chap manari 1 lere adu e square phang. Number 3, limit location si masisu limit e to the power x minus 5 minus 1 e to the power 5 se kamal lokthokhi bani. Adudi huzi e to the power x minus 5 makhados x minus 5 lere x tends to 5 or abadi makhad 0 lere. The standard result phanga bani na e to the power 5 from limit ki mamangna thamkro x minus 5 tends to 0 hani ibi mathaki asi haibadi x tends to 5 or x na 5 changabadi x na 5 te cross torabadi x minus 5 se tends to 0 changchingani. Standard result makhagi sika sika mananab sin mathaki limit se panjinna na bagi damaktari e to the power 5 into sigino 1 lere e to the power 5 tarani sigi limit e to the power 5 tarani sigi limit e to the power 5 oigadaba. Number 4, limit of this. Limit of this method to e to the power sin x minus 1 by x ni. Makha da standard result phana sin x fill up to rasima do sin x method ka thamgro hana leramba x to sin x ki makha da laikre. Function ki limit ti ano function ki limit into ani so function ki limit. Ano function ki limit ti 1 ga manane ani so function ki limit so 1 manane standard result to seasonally we get 1. Number 5, e to the power x masidagi sukwan e to the power 3 kamal lokthok ka si phangani masidi standard result lama phange masidi limit e to the power 3 the constant ni independent of x yaugdabani na limit ki mamana pocket kharo asum standard result sigi di 1 tarani e cube tarani. Number 6, this limit log c 1 minus cos x is 2 sin square x by 2 ga manai e to the power x oigadabani sigi limit sigi x as e to the power x e oigadabani. Rearrange to e to the power x minus 1 by x thamasi aduga sin x by 2 asina mathak x by 2 fill up direct irani whole square karani hinjing giba sigi x square da sigi x na yaladi hana gi mathak x to tare amuksu sigi 2 square of 4 dani 4 makhadari ba 4 mathak ki 2 ni yaladi makhagi 2 sigi manare sigi square jina sin da kara bi hana gi sin square x by 2 phange limit log 2 mamang chakro limit of this function into limit of this function. Sigi limit 1 line sigi limit to sin x by x or x by sin x limit sigi the x tends to 0 gidi 1 ga manare square karamang 1 square whose value is 2 phang. 7, limit location si logarithmic function log of 1 plus twice x the makhazu twice x thamna bagi 2 ma hapsalasi madu makhada half kibanin into toxin kibanina mathak into togun mathak togodob into the limit ki mamang na putoga thangre limit ki property seasonaraga we get sigi limit asidi 1 tare karam formula seasonary bano hairagadi limit of log of 1 plus x divided by x, x tends to 0 is 1 have a limit to seasonable. Sida base e half as we half to say half per seven. There is 2 function. Number I, limit of this function, limit of 1 plus x cube c must standard result phangna ba makha x cube ama fill up tore maduna sin x cube matak x cube fill up tore di makha x cube ni matak x cube ni x by sin x to whole power cube kare. Limit of ahar function, limit of any super function. Ahar function ki limit ti pura puri 1 tare, so x by sin x ki limit ti 1 tare 1 cube, there is 1 function. Thank you for watching video.